Hey guys, in this video we will be discussing explanation for a problem from June long challenge. So the problem name is Bella CIO. So in this problem it's given that the initial rate of printing the currency is P dollars per day and the production increases by every Q dollars in an interval of D days. So for example, after D days the rate is P plus Q dollars per day. Similarly, the production becomes P plus 2Q after 2D days and so on and so forth. So here we need to print the amount of money that they will be able to print in the given period. So in this problem, here we are given three test cases. So in this video we'll be discussing the third test case, which I feel should be enough to crack the solution. So let's directly jump onto the explanation. Okay, so here in this problem, in the third test case, we are given the capital D as 5, small d that is interval as 2, P as 1 and Q as 2. So what we're gonna do here is initially we will break the capital D into the number of intervals. So which we can easily do by dividing capital D by small d and then taking the lower bound of it. That is, but dividing 5 by 2 we get as 2. As you can see here, what we have done is break down the capital D into two intervals, two small intervals. That is, in first interval we get as 1 and 2. In second interval we get as 3 and 4, and the remaining one is like we get here as 5. So what we need to find out is basically we can break down into two separate cases. So I will explain you how this expression came. So in the first test case, basically we are considering only the broken interval ones. So as you can see here, for 1 and 2, for first 2 days, the production will be 2p. Then after d interval, like after two days, the production become p plus q, which we multiply again by 2. So this 2 is like the d interval, like number of days in that interval, and the remaining one is this one. So this case one refers to only these two one, and the remaining is the case two thing. So basically in the first case, what we are how this expression came is, so we are multiplying this p with z. So z is the number of intervals which we have found out in our step one. Then we add the contribution of q. So basically how this came is, this thing is nothing but say if we want to find the sum of first n numbers, so the sum will be n into n plus 1 by 2. So here in this case, the number of intervals in which we broke down is z, but since in the first before the dth day the contribution of q will be 0, so basically the the n terms will actually will reach up to z minus 1. So this is nothing but we need to find the sum of first z minus 1 numbers. So that is nothing but z minus 1 into z by 2. So in this way we get the contribution of q for these two intervals, and this whole expression we multiply it by d. So d is the number of uh, in the interval in which we need to break down. So yeah, so this is how we get the case one, and for case two, this is the remaining thing. So for remaining, we can easily find out by taking the modulus, and so here in this case we get as 1, which is the 5, the remaining one, and you can see that after the 2d days it becomes as p plus 2q. So this 2 is the k. So k, so basically k, let me rename it as z. So z in this case, so basically p plus zq, so which we have found out here, and we simply multiply it by the number of remaining days, so which is r. So when we add both of these, so that's how we get our final answer. So let me know how if you understood the solution, and comment below if you need further explanation for bitwise tuples as well. Thank you.